Okay. We are live as well. But people who are sitting and relaxing in their homes can join us. Okay. So, like I said, we are not going to have a lot of people today, which is both good and bad. But it's been the story so far that whenever I talk, people don't come. So I think the problem is me. I'm just kidding. But yeah, thank you so much for coming out today. Thank you so much for coming out today. We will have a few more people joining us, and apart from that, this is the audience for today. So I think we can have like really good discussion and understand more about recommender systems. Okay, so like we usually do, I think first I have to start with a word about our sponsor, UpGrad, who today unfortunately did not set things up for us, but it's okay, it happens. I guess there was some miscommunication from our side, and I think we'll rectify that next time. I will make sure that this doesn't happen. And yeah, so UpGrad, as you all know, is an online learning platform where they offer courses in data science, machine learning, and other fields. So if you are interested in any of them, you can check them out. And they are sponsoring us, so thank you for that. Very quickly, our agenda for today, as usual, we'll have an icebreaker. Then we have the discussion on recommender systems. We have an introduction on recommender systems, then we'll follow it with a discussion, and then we'll have some networking where we'll talk to each other on what we're doing and all of that. Okay, so quickly moving on to the icebreaker. We've already lost some time. So icebreaker, what we usually do. How many of you are here for the first time? First time. Okay, so majority are first timers, so we'll go back to old icebreaker. So obviously you both will not talk to each other because it doesn't make sense. So what we'll do is that you will turn to your person on your left or right, and you will ask about his qualification, his education, his background, and you will introduce him or her to the audience. Basically, this person will introduce the other person, another person will introduce the other. So we have around 5 to 10 minutes to do that, so we can get started. You three can, or you can. So you can break out. Yeah, if you know already, then it's. So you can talk differently. This is my. This was my second in retail domain from the last 2 years. I've been working as a professional in the basically from Madhya Pradesh. So it's usually some of the hands-on from my side. Use a lot of experiences, people reading related stuff, machine learning. From last 7 or 8 months, I've
he suggests me there is no register for this.
I have
completed in 2015. 15, yeah. 14,
You can last 2 minutes and then you go ahead.
What's usually banking purpose banking basically mostly I can say
people who onboard businesses for us.
mostly I can say this is a financial company. We work for electronic clients. So basically your daily usual task is data manipulation, data cleaning, what data we want, what you want. Again, some bank applications will be so you're from Rajasthan, Pali district. You know Mount nearby. So you basically from Rajasthan. You have done your graduation in this year itself. Bali, right? Velaram. Proceed in that financial domain for the last 4 months, and you are also very enthusiastic. You are doing that banking stuff. You basically switch to in your graduation. What you did in electronics or something?
Okay, so last 1 minute, or you can start if you're done. Oh, done? Everyone's done? Okay, you can start from there.
He's working right now. He has completed his MBA. And right now,
For the crowd, yeah.
and he's interested in analytics. He's very good at analytics. So he's interested in data science. So he's trying to shift his career. Very easy.
Okay. Yeah, so maybe you can.
His name is Farhan. So he's a engineering student in third year. So in computer science background, so Bangalore. So he told me that Imaad is his cousin also. So it's good to know, like he's trying to understand how things are actually happening. Eventually he'll be there. So
Okay, good. Yeah.
This is Shreya. She's currently working in a company called Business Technology, and she's she is a 2018 pass out, and she's recently gone into this field, and she wants to learn more about recommended systems, and that's why she's here.
He's Sakir, and he's from Hyderabad, and he was just attending one conference on concert on Friday. That's why he's like here, and he used to love to know about business analytics, and he wants to do something in the BI field. That's why.
So you came to Bangalore just for the concert?
Yeah, actually I had to meet some friends, and so I was free on today, so that's why I attended.
Yeah, nice. Thank you for coming. Yeah. So you can say we have people from other states coming to our meetings. Yeah.
So this is Belaram. He is recently 2018 pass out from computer background. Basically, he's working in that KPMG as a Python developer only. He was working in that financial domain, like fraud detection and banking related stuff. And he was very enthusiastic, very keen to learn that deep learning stuff, and that's why he is here.
Okay. Yeah. So you can give.
Yeah.
If you got anything, yeah.
This is my man, and he's from Madhya Pradesh. And he's completed his graduation in 2015 in electrical engineering. Now he's working in an IT company.
That's how you spoke. Okay, no problem. Yeah. So it's just to, so this is not very formal. You can say whatever you want, sir. Yeah. So that okay. Yeah. Go ahead, please.
Yeah. So he's Rohit. He's 2017 pass out. He's working currently at NIT Technologies in the R&D team. Their team basically does a lot of innovative stuff where they try to do some POC around market. They do a POC and then they hand over the POC model to once established, once they hand over the POC model to some other team, which then works on it and builds the product. So, to give you an example, something around customer base, how the customer interacts with some particular product. So that is what he is currently working at.
He's Pratik. So currently he's working in this ledger pay, this payment of sources companies there, and he's just 16 pass out, and technology is doing some backend technology like Python and PHP like that, and he's living in near Kolkata. And this
is very far.
Yeah. I think Hyderabad was even further.
So yeah, that's what we're going to say. Like we have people from other states, from Telangana. So no, thank you so much for coming. So this is a very informal kind of. So I want to get that vibe because I don't want everyone to be like scared or not contribute. Mostly whenever I've said this before also, whenever I'm speaking as part of these meetups, I want everyone to contribute because that's how I see a meetup. We've had guests as well previously. We had Mitali who had spoken and all of them. So whenever they come, I cannot control how the meetup goes. But whenever I'm speaking, I don't want to speak much. That's my intention, so that everyone contributes. Everyone is skilled in some area here, and when you contribute, your knowledge increases and everyone else's knowledge increases. So that's the motive. That's why Icebreaker, so that you can relax with the person who's sitting next to you, right? Okay, so with the icebreaker done, I hope the ice is broken. Let's move on to recommender systems. So, have you all heard of recommender systems? Please come. You can take a seat here or wherever. So, how many of you? Okay, so we can continue the icebreaker. Yeah, you guys can introduce yourself and then we'll go ahead.
My name is Monica.
You can sit first. Yes.
I'm pursuing my business statistics.
Okay. Very quick, very good introduction. Yeah.
I'm Divyashri. I'm presently working in a company.
Okay. The company has a name.
Biotechnic.
Okay. Welcome to the meetup. So that's what we just finished our round of introductions right now, and then you walked in right at that moment. So thank you so much for coming on a Sunday afternoon when most people are sleeping. Okay, so back to recommender system. So have you ever heard of the term recommender system? I'm sure you must have heard, but in what context? Anyone?
Like I've heard about recommender systems like first through Netflix. Like that was the first time when I heard about recommender systems, and then actually while I was doing my internship at Virgisa, I worked on POC. It was about giving right coupon to the right customer at the right time. So for that, like we use SVD to build a recommender system based on the frequency matrix.
Okay. So you will make an interesting point. So when was the first time you heard about recommender systems? He said Netflix. Anyone else? First time. Interviews. Really? Okay, you've heard, but when was the first time? Okay, you've learned about it, and then you realize I've been using this all my life. So when was that? What was your first interaction with the recommender system? Maybe e-commerce. I think most of us started with recommender systems there, right? Okay. So I have a definition for recommender. Okay. Before that, what is your definition of recommender system? I have a definition, but before that, what is your definition? What do you think is a recommender system? Have recommender systems existed before the internet? According to you, were there recommender systems before the internet? Now we see everywhere on the internet there is a recommender system, but where recommender systems existed before the internet? Yes, where? This is an exercise in thinking. That's it.
When you go to a shop frequently, the owner of the shop might know you well, and he might actually recommend products to you based on your previous interactions with him.
That is true. That is one. Has anyone experienced that? Yes. When you go to a restaurant, you ask the waiter, "What's your recommendation?" Right? That's a recommendation system in itself. Anywhere else? Have you tried getting recommendations?
Word of mouth from your friends.
Word of mouth? Example? Any example?
Friend recommending.
So friend says you can buy this phone, and then you go ahead and buy. So all these systems have existed, right? Recommender systems is not something that has come because of the internet, but it has become scalable because of the internet. Now you can use them, and now it is done by machines instead of being done by humans. So that is what we are going to understand how machines are doing that. How humans do that, I still don't understand, because it's a very complex mix of how do you think that this thing might be suitable for that guy? Of course, you have some features that you create in your mind. Okay, this guy's personality is so and so, and then you think all of that. But then, like a waiter, you would ask him for a recommendation. Like, what's your recommendation? What would he recommend according to you?
Like he'll ask you like, do you like spicy? Like,
So, does he ask you that, or would he go ahead with the most popular dish of the restaurant?
Most popular.
So that is also one of the types of recommendations we'll see further. So anyway, let's look at the definition that I have. So a recommender system is a system that aims to match users, products, contents, brands to other users, products, content, brand using some notion of similarity. And I think the last part I added this because it's important to have some similarity, or else your recommendation system is just like, it's not useful if you don't have any similarity, right? So in other words, the recommender system tries to match an item of interest to another item of interest using some prior interactions or data. We're talking about the waiter, right? Does he fit in this definition? Does his recommendation fit in this definition? You have to contribute, or else this meetup is dead. No. Why?
Because he doesn't tell that similarity. We doesn't know about yours, like what suits you. Basically, most of the
In this, not this. So here, what I'm saying, recommended system tries to match an item of interest to another item of interest using some prior interactions or data. In my opinion, maybe because what data he has is the sales of the dish or the general feedback on the dish, but he's not doing. Okay, we'll come to that. He's not doing a collaborative filtering. He's doing a content filtering here, where he's actually seeing how the dish is and what feedback it is getting, and then recommending, regardless of what your background is, right? Okay, so this is an overview on what recommend system is. Like, it's not very technical, not very deep, but this is what it is. We'll move on to understanding where recommender systems are used today. I think most of you know where they're used, but it's obviously good to get an introduction. So now I've just put the logos in here. Can you guys recognize the logos?
Yes.
Yeah, let's start with the first one.
Amazon.
Is this Amazon?
Yeah.
Okay.
YouTube.
That gives it away. Yeah. Okay, that is representative of social media. New York Times, as it is.
Spotify.
And then we have some heard this. Zomato.
Swiggy.
Have you heard of this company? I'm not sure if you've heard of this company. So the name gives it away, but Stitch Fix is a European company where they use data science, machine learning algorithms to recommend fashion or to recommend styles to a person based on his personality. So they are your personal stylists basically, but they use all these techniques and core of course. So what you see here? Do you see different industries? Yes, you see different industries. You see what industry is this?
E-commerce.
E-commerce.
Content.
Content sharing.
Okay, let me write down what industries are here. So first one is e-commerce. Next, content or video?
Yes.
Video. Next, we have social media. Next,
News.
news. Next,
Music.
music or sound or audio. Music or audio, not sound. Next,
Logistics.
sorry,
Logistics.
logistics. Zomato and Swiggy.
Yeah, it's food. Like
Logistics or food?
food.
Food logistics.
That's all.
But okay, we'll come to that. Next is fashion
Next is knowledge.
and eighth is
Knowledge.
knowledge industry. There's a knowledge industry.
Knowledge sharing.
Knowledge sharing.
Education.
Q&A.
Q&A.
That's what they call. So if you go on Quora, they will call them a question and answer platform. So that is that. Okay, so we have how many? Around 8 industries. Any industry that you interact with on a daily basis?
E-commerce.
News, video. So is your everyday life affected by recommender systems? Yes, right? So far we know about these industries, but I would like all of us here. So recommender systems have fundamentally changed the way people interact online. They're used by almost all the major consumer technology companies like Google, Facebook, all of them. However, their potential can be tapped in other industries as well. So we are going to break out now, like how we usually do, and try and figure out which industries can we apply recommendation systems to, where we actually don't right now, because we know the use case. Or do you want us to go through the use case? You know what e-commerce recommends you. Customers who have bought this also bought that. People you may know in the case of social media, videos you have watched, news you might like, and so on and so forth. So these are the industries we know that has been affected by a recommender system, but there might be industries that have not been affected. And I have a few in my mind. But I want us to discuss that, and we'll take 5 to 10 minutes for that, and we'll break out into group 1, group 2, and whichever group gives me the most industries will win. Okay? So this is your group. You can form a group here, form a circle, or I don't know, semicircle. We'll do that for 5-10 minutes, and then we'll proceed. Okay? So your task is to come up with industries and use cases where you can use recommender system. And basically, you know where recommender systems are used today. You know how they can be useful. So give me industries and give me use cases.
Something new or just
new? If you want to give for the same thing, then what is the use of this? Okay, so something new. We'll write them down here. New industries and their use cases, so that we understand better. I mean, we'll come to that. Yeah. So yeah, we have 5-10 minutes. We have so many industries. We have tea industry, we have coffee industry, we have fisheries, we have agriculture, we have what else? Logistics. No, food is separate. Like especially Swiggy and Zomato is not even food. It is not like logistics. They do logistics, but they just sell food. That's it. So their problems are different. Their problems are how can they recommend better logistics, or I don't see how they can do that. But okay, so we have these industries. I mean, I'm just throwing out industry. So you can think for another 5 minutes and then we'll start. And I also want the use cases, not only the name of the industry. How will you use it? Like, for example, for social media, you would say people you may know. So.
We've got 6-7 by the. No. I mean, we can actually. We have 6-7 by the.
Okay, last 2 minutes we have. Last 2 minutes. Are we done? Let's see who wins. Okay, so we have reached to the end. Do you need some more time? No. Okay, so we have team A, team B. Everyone, I mean, team A will start first, team B will give. And if you use one industry, you cannot use the same industry. You will discuss. Okay? So let's see who gets the maximum number of industries. So team A, what's your industry?
First is that OLX buy and sell some items, used items.
OLX. What is the industry called?
Industry is at a
Used items.
second-hand marketplace.
Used
items.
Used items. Okay, and what will you recommend?
OLX, Quicker.
Okay, OLX. So what do you recommend?
Items to buy, items
To save.
not sell,
Items to
items to buy.
Recommend based on the other users who have bought.
And also personal preferences.
But I don't think OLX collects data on personal information. Does it collect? I don't know. I have an OLX account, but I've never given any personal information.
It doesn't do it, but it can do it.
Can, but I will never give my opinion based on.
No, at least they have that, like if you're looking for some bike or anything, they'll give you options for the bike.
Similar bikes or.
Can you look location wise?
Okay, so that is one. We have one used item industry. Okay, next. Dating. Dating. Right away dating, yes. And what do you recommend here? Okay, person recommendation. Anything else you can recommend here? Products? Can you sell? Similar
Interest.
So you based on similar interest, you will recommend a person, correct?
It's like apps use an elo score to match two people.
So you match people, and I'm just thinking, can you sell anything here? Like, for example, would Tinder sell chocolates on Valentine's Day, or some guys might like whatever flavor of chocolate they might like, or something. I don't know. Maybe some product. I'm going to add a whole list. Okay, so we are done with the first industries.
Second.
So you had this industry meetup?
Yeah.
Of course.
Meetup, like event meetup, and like this meetup.
Meetups. Okay, that's an industry I didn't know. I mean, there's no money being made in this for sure. So I don't know if that's an industry. Yeah. So what would you recommend in meetups?
Different
There is an app events.
Based on the past.
Okay, so that's not meetups. That is events. Well, I know there's no money in meetups. With events. Events, yes, there's a lot of money.
Like
What do you recommend?
Like same mindset, people will recommend it to go in some events, like
Similar events. So you can recommend events. Can you recommend?
as persons, like
Trips.
You can't recommend the people, right? On your
No,
platform.
no.
On Book My Show, I will not say this guy also is booking
Trips we
MS
can-
Dhoni. Go watch it. Huh? Trips. So similar events.
yeah,
Similar.
yeah.
Anything else? What can you recommend? So you can get, and trips, how will you do that? You will do that based on their data, the person's data.
Their past experience.
Anything else can we recommend here? Any UKs can also say any idea
What they like in the past.
what they liked, previous events, same thing, similar events. Okay, fair enough. Anything?
Other than this one, like the next one.
Next one.
Nutrition.
Nutrition. Wow. Okay. What will you recommend in nutrition?
Like the diet that he's supposed to take based on his health conditions and
Diet. Based on his health condition, that is a recommendation. Yes. Anything else you can recommend? Okay, if you're giving the nutrition, yes. Anything else?
Like it could expand out of this, but we can say like people of your age working this much hours are doing this exercise to stay fit. You can also do the
Exercises. Did you guys think of this also? Yeah.
No.
Okay. Events you had thought.
we had thought about trips like travel.
travel.
Okay. Third, travel is also a separate category. I would say.
So you can
Supermarket, like
This
no, big basket,
Retail.
go first and
retail.
retail e-commerce are same. No?
E-commerce, like
So if you whatever
whatever is
you go,
part of e-commerce, just no.
no, if you go and buy
Like this, these supermarkets also
Like big basket,
places
go first.
and they recommend
You get
if
it.
you buy
E-commerce part
certain
of it.
stuffs, they
Offline
give a
stores.
combos and offers on that products.
so most of the use cases are from e-commerce, right? Yeah. Okay, retail. Okay, we have one space for one more. So
Just one more. We have like
okay, we can read them out loud and see who has more.
so next is insurance.
Insurance. And your product that you're going to recommend here is
LIC policies.
policies.
Recommendation.
I'm still searching for an industry which is like not commonly seen every day. Like you can see retail, you can see insurance, event. But
One property type. No? That's
okay, insurance policy, anything else? Nothing. Okay. So here,
Agriculture.
agriculture. In this,
Like based on soil and based on weather, we'll recommend like farmers as per their
recommend what?
crops and
The crops that you have to harvest.
as per geographical location and factors.
Anything else? Here.
so like medical industry, pharmacy and all that.
Healthcare, pharmaceutical, which one? I work in pharmaceutical, so I know there's a differentiation there.
I would say
Both
pharmacy.
pharmaceutical as well as healthcare.
Okay.
If there is an emergency case and doctor is not there, and if patient do have his prescriptions, so we can recommend based on the prescriptions or their its health test.
So will you take a medicine which is given by a doctor, not by a doctor, but
by a recommendation system.
By a recommendation system. Will anyone of you over here?
I wouldn't.
You will not, right? Will anyone of us over here take a medicine which is given by not by a doctor but by a machine which has all your previous data?
In case of emergency.
You would rather die in case of emergency.
But when cross-check game,
if you live enough later. No, I'm just saying because the thing is, it's an ethical issue, right? Like a lot of people would not want to do that, even though it's possible today. I attended a conference where Dr. Devi Shetty was speaking, and I'm sure most of you have heard of Dr. Devi Shetty, right? So he was telling that computers can actually give better recommendations for your problems when you come to us, but the human element is missing, so you will not trust them and you will not buy from them, even though they give you a better recommendation. So that's why I asked you this question: like, will you take a medicine that is prescribed by a doctor, even though it might be better, even though it might perform better than the state of the art? Like if you see Professor Andrew Ng, every other day he has papers coming out that are performing better than state of the art in X-ray detection and all of that. But will you actually get it done? I think there is a use case here where people who are actually not aware, I mean, you can first help them out. Like they don't know anything about what is happening, maybe, and there's a shortage of doctors. Like a lot of doctors don't want to go to rural areas, for example.
yes.
And and what government has tried to do is put mandatory 1-year service, which doesn't work well with the doctors. They resent, and then a lot of issues are happening. So maybe this might be a solution for treating people in rural areas. But yeah, nevertheless, this is something you can do, right? This is interestingly, this has been possible since the last 10-15 years, but nobody wants to use this. Okay, pharma, yes, pharma. A lot of things are happening. Pharma, I can tell you because I work. I'm also building a recommendation system myself in pharma. That we can go to the details later. But pharma, yes. Okay, one unique industry if you guys have. One which is not commonly
Job portal.
Sorry?
Job portal.
Job portal. Every day you see it, right? Like okay, job portal. But yeah, LinkedIn, Monster, Indeed, all of them give you recommendations, recommended jobs, recommended companies.
Yeah.
In fact, while I was preparing these slides, I went through LinkedIn's recommendation algorithm, which they use to recommend companies, So I'm not included that in my slides, but when I was going through, I saw they have built a hybrid system. Of course, content-based, collaborative-based is not going to be enough for their needs. They built a hybrid system, and what actually they did when they started building, they realized that they can have a lot more use cases. Not only one use case, like people you may know, they recommend people you may know. They also recommend companies like your company, jobs like your current job and all of that. So they build a horizontal system. They didn't go vertical. They have a system in place. I can search the paper up, but I don't remember the name. So they have a system in place which can which can still give you a recommendation when you change the data. If you give people you may know data, it will give you people you may know. If you give companies data, it will give. So it's robust. You're not building the system again and again. You're building the system once and changing the data sources. So they built a system like that. They realized it early on that they can do a lot of things. So that is about jobs, like I said, right? Yeah. Any other industry?
We have like 4 unique.
Yeah, you can go ahead.
Finance and marketing, chemical, property tax, and legal.
Finance and marketing. What are the use cases in finance and marketing?
It's a combination of finance and marketing. Like in the banking domain, you can have if the bank has an app, you can actually use the transaction data of the customers to give right coupons to the thing that I worked on, right coupons to that's a combination of finance and marketing. Like you're doing it for a bank, and it's actually a marketing example, giving a coupon to the customer.
Okay. And finance and marketing, what else? Chemical. What recommendations in chemical?
Chemical as well as metallurgy, you can combine both of the things here. And for metallurgy, it's like our chemical synthesis, like they can have better recommendation, like which alloys they can use in which kind of.
Sure. Next.
Property tax.
Property tax.
How much tax should you
collect
on a property, certain property? So you can look out for its feature and
okay.
With a dynamic.
So and what else?
Legal.
Property tax is an industry, okay.
It is like one of my seniors doing that thing in Bihar. So they found out that they can actually charge 2.5 times more tax on the similar property. So like the government was undertaxing those properties. The other thing is legal, like what all, if you have a certain case, what all paths you can take.
Yes,
to
that definitely.
create this grievance, right? And another is gaming industry, like this gaming also, like this.
So as we see, recommender systems are everywhere. Tell me an industry where you cannot use recommender system. Now, apart from healthcare, you can, but you will not. So yeah, so it's very difficult to think of an industry where you cannot think of a use case for a recommender system. So now we know broadly where we use recommender systems and what use cases we have. Let's look into the techniques of recommender systems that are actually followed. Okay, so we have majorly two types of recommender systems. The first is content-based, and the second is collaborative filtering. What I've done here is I've divided this based on types of data. Like this is your tabular data, this would be your text data, and this is your image or video data. So again, what we do most cases like here also we discussed that we have a feature extraction phase where we look at the data. If it's a tabular data, we put the features in the column based on the domain that we're working in or based on the use case that we have. This could be either ratings or preferences or anything depending on the industry. So it's not specific to a particular technique, and this can be anything. So you do this, and then based on whatever data you have, we can either do content-based filtering. We'll come into what exactly these are. We have a very special guest who's going to be telling this to us. But so what is content-based filtering and what is collaborative filtering? We'll come into that. So you do feature extraction, you get the data you have, then you do your filtering, and then you get your recommendations. Similarly for text, I have some experience. I've been working on a lot of text data. So what you do with your text is initially you convert it into vectors, you do your vectorization. There are multiple ways of doing that. One of them is TF-IDF, which stands for term frequency inverse document frequency, where you take the frequency of a particular term in the document, and then you average it over the set of documents that you have. And then word vectors, these I think after the paper released by Mikolov et al. In 2012 by Google, word vectors have been used everywhere in natural language processing. These are also, word vectors are the default vectorization method nowadays for a lot of NLP problems. And yeah, so you do this, and once you convert to vectors, vectors are your features now, and then you use those features, and you can do content-based or collaborative-based filtering on that. And then you have image. So I had to choose a cat because cats are viral on the internet. So and cats were the ones that were, I think, in the image net. You have a lot of cats. Anyway, I'm confusing. So you have cats. You do feature extraction. You have a convolutional network which will extract different features at different layers. You can use that and then do your recommendations. So I don't see any other possibility of a data type that can exist. Like you have your rows and columns, your tabular data, you have your textual data, you have your image or video data. Sound data, yes, you have audio data which you can extract features again. I not included that here, but you extract features from that. Your features will vary based on what your optimization function is, or what your not based on optimization, based on what you're optimizing for. So what you're targeting, and that's in general how recommender systems will go to work based on different data types.
How do we convert word into vectors?
How do we convert word into vectors? Depends on the technique you want to employ. So in case of TF-IDF, what I will do, so word vectors, I will take a neural network, one layer neural network. TF-IDF, what I can do is take the frequency of each word occurring in the document, the number of times a word occurs. That is bag of words, and then you, okay, first of all, bag of words is the simplest form of vectorization. What I mean with that, by that is, if you see this text, I will take this text, remove certain words that occur most frequently, like stop, they're called stop words in NLP terms. So you would remove is and all of these kind of words. And then you would go ahead and vectorize, because your algorithm cannot understand English as is, right? So you have to vectorize that. So you could either take a bag of words, which basically means you take all the words in your document, take their counts and then put them in a bag. And then you're saying this is what the word I have and this is the frequency of each word. So now it's vectorized already. So that is one representation. These are more advanced representations. So that I think I'll cover that in detail when I have an NLP session, because I do a lot of NLP, so I know what we can do with that. We will do that later, but in general, that's how you convert. All right. Okay. Content-based filtering. Anyone knows what content-based filtering is? Oh, okay, let me just introduce something. Content-based filtering involves mapping of each item into a feature space. Both users and items are represented by vectors in the space. Item vectors are they measure the degree to which the item is described by each feature. User vectors they measure the user's preference for each vector. Ratings are generated by taking dot product of user and item vectors. So this might not make that much sense without an example. Like when you take an example, this makes a lot more sense. I think I can write it down. Oh, I have an example. I don't have to write it down. So basically, what you do in content-based filtering is that you have a set of ratings that are already taken by the for a set of users. So in case of movies is the most popularly used example when it comes to recommend. So you would go to certain users, ask them to rate certain movies. Like, what do you think about this movie? What do you think about that movie? And I'll ask them to rate between, let's say, 1 to 5 or 0 to 5. Okay, this is your rating. I like this movie better. I didn't like this movie. So they would give ratings, and those are your items in this case. Movies are items. Your users are your users who you're asking. So what you do, you convert them into vectors again. How do you do that? For item vectors, you go ahead. In the case of movies, you would think of features like, does this movie contain, I'm just thinking of features right now, a superstar. Would you like a movie with a superstar? Is this movie animated? Is this movie for kids? So you could take that data as well from the user along with the ratings. And then that way you get content based, then that way you understand you're representing your item in terms of features or in terms of vectors. So how do you actually describe that? That vector, so that is your item vector. User vector is your rating, which the user has given for a movie. And then you take a dot product of these two, and then that is the rating that the user would give for a given movie. We'll go through an example. I have an example. It will be easier for us to understand. So, who likes biryanis over here? Nobody? Nobody likes biryani? Great. Spicy biryani? No. Okay. So, biryani, but everyone knows what biryani is, right? So, biryani can be described by certain features, and I have taken 3 features here. For example, spicy. Does it contain basmati rice, or how much does it contain basmati rice, for example, and how much of cardamom does it have? How spicy is it? How much basmati rice does it have, and what is the content of cardamom? So these features are your item features. These are features of your item. Your item of interest here is biryani. You want to be able to recommend biryanis to users. That's the problem you're trying to solve. You want to be able to recommend biryanis to users. So what do? You go ahead, take the features of biryani, and here, for example, Hyderabadi biryani has 552. I don't know if this is true. Please forgive me if this is wrong, but Hyderabadi biryani is apparently very spicy. This is a mocked up value. This is not real. So it rates 5 on the spicy scale. Basmati rice is 5. Cardamom is 2. There's not much cardamom in Hyderabadi biryani. Dum biryani would be 3 minus 5, 5 minus 5. So there's no basmati rice at all in dum biryani. US biryani, made up, mocked up biryani, -4, -5, -5. So it's not very spicy. It has hardly any basmati rice. It has hardly any cardamom. So this is the problem setting. You want to be able to recommend different kinds of biryanis to different kinds of users. And we have 2 users, Rocky and Mayur, who have already given out their preferences. So you went to Rocky and you asked, what kind of biryani do you prefer? And then he says, I want less spicy, I want basmati rice, I want this. Okay? And then you have Mayur, you've taken his features as well. So how would you go about this? So if you want to give predictions for Rocky, you would like I said, you have your item features, you have your user features. You would go ahead and then take a dot product of that. By dot product, what you would do is take each feature and multiply with its corresponding, take each vector in Hyderabadi biryani and multiply with the corresponding user. So 5 times minus 3 plus 5 times 2 plus 2 times minus 2 is minus 9. Similarly, this is for Rocky, right? So everything will be multiplied with Rocky. So 3 times minus 3, minus 5 times 2, 5 times minus 2, minus 29. Similarly for this. And then what you observe is that predictions for Rocky is the highest, most likeliest that he would like. So because it's positive and it's the highest, so you would say, Rocky, according to your taste, I'm recommending you US biryani. And how did I do this? I had to go through this content-based filtering. I had to go ahead, get the features, get the users' data on the biryanis, and then get out the predictions.
Why the maximum value?
So that is the most likely value, right? So the rating is on a scale of 0 to 5. So you would say 5 is positive, minus 5 is negative. So if you don't like, you would say minus 5.
Okay. But if it is not present in the, let's say basmati rice, right? Then when I define US biryani, it says basmati rice is minus 5. That means it doesn't have any basmati rice.
No, so it's not binary here. It's in this case, I mean,
let's say it's
less quantity.
Less quantity. It does not show the preference over there, or it does not show whether I like biryani or basmati rice in biryani or not. Whereas for Mayur, minus 3 means that he doesn't like basmati.
He would. So again, on a scale of 0 to minus 5, I don't want any basmati rice at all.
For users, that makes sense. For biryani, it has a very different definition. So is this something expected, or?
I didn't get your question. So you're saying?
I'll repeat. Let's talk about basmati rice. For Mayur or Rocky or any user, it means that whether he likes basmati rice in biryani or not.
No, it's not binary. That's what I'm saying. Here it's a range.
Yeah, let's talk about the range. How much does he like basmati rice in the biryani? Whereas for these biryanis, the values.
So okay, you're saying here there is no basmati rice because it's negative of 5.
I'm saying it does not represent the preference over there.
Oh yes. Okay, you're saying that it's not more about preference, but it's about the feature itself.
Yeah.
Yeah, so here this preference also is learned. This actually is not asked, so we'll come to that. Okay. This is what you get from the content. I mean, from the item itself. So when you do feature engineering, you do this. You're correct. It's not a what you would say. It's not the preference, but it is the feature itself.
Both the things that are being compared are a bit different.
Yes. So this is actually learned. This is not. So we'll come to that. Okay. So and who better than Professor Andrew NG to explain this to us? So I have this video because I didn't want to explain something and miss out on something. So what I did is went ahead and got a formal introduction from a video where he's explaining this formally, this problem statement. And we're going to have a look at that. And then maybe this will clarify it a bit better.
More formally, here's how we can write down the problem. Our notation is that Rij is equal to 1, the user JS rates movie I, and Yij is the rating of that movie if that rating exists. That is, if that user has actually rated that movie. And on the previous slide, we also defined these which is a parameter for each user to. Let's suppose that for each of these movies, I have a set of features for them. In particular, let's say that for each of the movies, I have 2 features, which I'm going to denote x1 and x2, where x1 measures the degree to which a movie is a romantic movie, and x2 measures the degree to which a movie is an action movie. So if you take a movie, Love at Last, 0.9 on rating on the romance scale, so it's a highly romantic movie, but 0 on the action scale, so almost no action in that movie. Romance Forever, so 1.0, a lot of romance, and 0.01 action. I don't know, maybe there's a minor car crash in that movie or something, so it's a little bit of action. Skipping one, let's do Swords versus Karate. Maybe that has a 0 romance rating, no romance at all in that, but plenty of action. And non-stop car chases. Maybe again, there's a tiny bit of romance in that movie, but mainly action. And Two Puppies of Love, again, mainly a romance movie, action long. So if we have features like these, then each movie can be represented with a feature vector. Let's take movie 1. So let's call these movies, movies 1, 2, 3, 4, and 5. But my first movie, Love at Last, I have my two features, 0.9 and 0. And so these are features x1 and x2. And let's add an extra feature, as usual, which is my intercept term feature, x0, which is equal to 1. And so putting these together, I would then have a feature x1. The superscript 1 denotes is the feature vector for my first movie. And this feature vector is equal to 1. The first 1 there is this intercept term. And then my two features, 0.9, 0, like so. So for Love at Last, I would have a feature vector x1. For the movie Romance Forever, I would have a separate feature vector x2, and so on. And for Swords vs. Karate, I would have a different feature vector x superscript 5. Also, consistent with our earlier notation that we were using, we're going to set n to be the number of features not counting this x0 intercept term, and so n is equal to 2 because we have two features, x1 and x2, capturing the degree of romance and the degree of action in each movie. Now, in order to make predictions, here's one thing we could do, which is that we could treat predicting the ratings of each user as a separate linear regression problem. So specifically, let's say that for each user j, we're going to learn a parameter vector theta j, which would be in R3 in this case. More generally, theta j would be in Rn plus 1, where n is the number of features, not counting the etc. And we're going to predict user j as rating movie I with just the inner product between the parameters vector theta and the features xi. So let's take a specific example. Let's take user 1. So that would be Alice. And associated with Alice would be some parameter vector theta 1. And our second user, Bob, will be associated with a different parameter vector theta 2. Carol will be associated with a different parameter vector theta 3. Dave a different parameter vector theta 4. So let's say we want to make a prediction for what Alice will think of the movie Two Puppies of Love. Well, that movie is going to have some parameter vector x3, where we have that x3 is going to be equal to 1, which is my intercept term, and then 4.99, 0. And let's say for this example, let's say that we've somehow already gotten a parameter vector theta 1 for Alice. We'll say later exactly how we come up with this parameter vector. But let's just say for now that some unspecified learning algorithm has learned the parameter vector theta 1.
So, like I said, this is what is learned by the function.
So our prediction for this entry is going to be equal to theta 1, that is Alice's parameter vector, transpose x3, that is the feature vector for the Two Puppies of Love movie number 3. And so the inner product between these two vectors is going to be 5 times 0.99, which is equal to 4.95. And so my prediction for this value over here is going to be 4.95. Maybe that seems like a reasonable value if indeed this is my parameter vector theta 1. So all we're doing here is
so I think this example makes it much clearer than what I was explaining. But any questions on this? Anyone? So what is actually happening here? How did he get this 4.95? Any idea? So to get that 4.95, what he did, he multiplied theta 1 transpose with x3. Theta 1 transpose is 0.50. How did he get this? He'll get this via a learning algorithm, which he said you have a linear regression cost function, and then you will get this theta 1 parameter, and then you have your x3, which is your here 0.99 and 0. X-intercept 1, you add your x-intercept 1, and then you have 0.99 and 0, which is coming from your x3 for this particular movie. And then the dot product of these two will give you the rating for this. So these function, this is your feature engineering part, where you understand the content itself. You can add more features to this, or you can. So this is where you are actually understanding how the content is, or what you want, romance, action. So that's what we were seeing here, right, earlier. So we had this features, right? Spicy basmati rice, cardamom. So that would be your features there. Okay, so that's in general about content. If you want the formal introduction, you can go ahead and watch it from
more formally.
This.
Here's how
I can just show you the cost
now,
function that they're trying to minimize.
By the number of to fit the parameters theta j. Then let me add in my usual regularization term here of theta j. Two.
So this theta j is actually learned by minimizing this cost function by using either gradient descent or any other optimization algorithm. You have a set of test data on which you have your predictions, and then these predictions are given by models, and then you have your least. It's almost similar to your least square regression equation, and then you add your regression term over here.
And when I minimize this, I should still get the same value.
So that's what happens in content. We'll go ahead and look at collaborative. Again, collaborative filtering is, I think, something which you're more familiar with because I don't know if you've seen when you're on Amazon, it says customers who bought this also bought. So it's trying to match you to similar customers. So like the slide says, the key idea behind collaborative filtering is that similar users share the same interests and that similar items are liked by a user. Collaborative filtering takes into account only the ratings specified by the user. So how do you do this? In this case, we'll have a data set which is a ratings matrix. Those columns correspond to the items which you want to be able to predict for, and your items, your movies, your biryanis or whatever. So this is what is your item, and then your rows are your user. User 1 gave a rating of 5 for, let's say, Dangal, or user 1 gave a rating of 0 for some movie. I don't know. So your user 1 would be a row, and your columns would be the movies for which you're giving ratings for collaborative filtering. We'll also listen into what Professor says here.
In this video, we'll talk the algorithm that we're going to talk about has a very interesting property that it does what is called feature learning. And by that I mean that this will be an algorithm that can start to learn for itself what features to use. Here was the data set that we had, and we had assumed that for each movie, someone had come and told us how romantic that movie was and how much action there was in that movie. But as you can imagine, it can be very difficult and time-consuming and expensive to actually try to get someone to, watch each movie and tell you how romantic each movie and how action-packed each movie. And often you want even more features than just these two. So where do you get these features from? So let's change the problem a bit and suppose that we have a data set where we do not know the values of these features. So we're given a data set of movies and of how the users rated them, but we have no idea how romantic each movie is, and we have no idea how action-packed each movie is. So replace all of these things with question marks. But now let's make a slightly different assumption. Let's say that we've gone to each of our users, and each of our users has told us how much they like romantic movies and how much they like action-packed movies. So Alice has associated a parameter vector theta 1, Bob theta 2, Carol theta 3, Dave theta 4. And let's say that we also use this. Let's say Alice tells us that she really likes romantic movies, and so there's a 5 there, which is the multiplier associated with x1. And let's say Alice tells us she really doesn't like action movies, so there's 0 there. And Bob tells us something similar. So we have theta 2 over here. Whereas Carol tells us that she really likes action movies, which is why there's a 5 there. That's the multiplier associated with x2. Remember, there's also x0 equals 1. And let's say that Carol tells us she doesn't like romantic movies, and so on. Similarly for Dave. So let's assume that somehow we can go to our users, and each user j just tells us what is the value of theta j for them. And so it basically specifies to us how much they like different types of movies. If we can get these parameters data from our users, then it turns out that it becomes possible to try to infer what are the values of x1 and x2 for each movie. Let's look at an example. Let's look at movie 1. So that movie 1 has associated with a feature vector x1. And Yeah, this movie is called Love at Last, but let's ignore that. So let's pretend we don't know what this movie is called. So let's ignore the title of this movie. All we know is that Alice loved this movie, Bob loved this movie, Carol and Dave hated this movie. So what can we infer? Well, we know from the feature vectors that Alice and Bob love romantic movies because they told us that in the eyes here. Whereas Carol and Dave, we know that they hate romantic movies and that
So you would collect this data on Alice and Bob, where they said that they like romantic movies, and Carol and Dave
users 3 and 4, Carol and Dave gave us.
have given their ratings already. You need to have this data set.
One is loved by Alice and Bob and hated by Carol and Dave. We might reasonably conclude that, you know, this is probably a romantic movie. There's probably not much of an action. This example is a little bit mathematically simplified, but what we're really asking is what feature vector should x1 be so that theta 1 transpose x1 is approximately equal to 5. That's Alice's rating, and theta 2 transpose x1 is also approximately equal to 5, and theta 3 transpose x1 is approximately equal to 0. So this would be Carol's rating.
Yeah, so you have your rating for this movie. You're trying to figure out if it is a romantic or action movie. What you're doing here, like, so they've given the rating of 5 for this movie. Alice has given 5, Bob has given 5, and they've already told that they like romance. And Carol and Dave have told us they don't like romance, right? They like action. So basically, you're multiplying this and you're trying to infer this. Sorry, you're multiplying theta. Yeah, you're multiplying theta into x1 such that it gives you 5.
Like, you know, x1
which is your
equals 1, that's the intercept term, and then 1.0, 0.0. That makes sense given what we know of Alice, Bob, Carol, and Dave's preferences for movies in this movie. And so more generally, we can go down this list and try to figure out what might be reasonable features for these other movies as well. Let's formalize this problem of learning the features xi. Let's say that our users have given us their preferences. So let's say that our
these are your user preferences. Your theta that you've already collected. You want to understand what is your x.
And we want to learn
what is the feature that
for movie number
we can
I.
use to recommend.
What we can do is therefore pose the following optimization problem. So we want to sum over all the indices.
So that's what you would do in the case of your collaborative filtering. And yeah, so it's just full screen. Yeah, but you have a problem called the gold start problem, because without data you cannot start. And so you need to predict ratings. You want to be able to predict how much a user would like a new movie, but you also need ratings to predict. You also need to get that ratings. So this system where you cannot place into production from day one because you don't have the data to actually do this. So gold start problem arises since you're explicitly correcting rating, and if you don't have enough ratings, not correcting anything. What you can do as a workaround is to use implicit feedback. So rather than going around asking the user, hey, can you go and review this movie for me? Look at the movie collection records, for example, or look at the ticket sales, where you can understand for this demographics, this movie is not doing well. So you can understand that in this area, the movie is not doing well. Maybe people of this background or this lineage are not interested in a movie of this kind. So you get that kind of an implicit data rather than explicitly going asking the user. For other things, this is actually used a lot in search. So what they do is they take your search patterns. When you search for some term, when you're actually searching Google, right, it shows you related searches, right? So whatever the user had searched first and then went on to search for the next time, they use that and then they add that to the list. That user, this was the path. So he searched for this first, and then he searched for this, and then this is what you might be searching for. And the next time you search for the same term. So things like that. So that is an implicit feedback. The user did not tell me that show me this next, but the system itself has understood that the user might want this next. Because this person A searched for bikes, then the person A searched for adventure bikes, person A searches for sports bikes. So person B comes, he searches for bikes. He said you might be interested in adventure bikes or sports bikes because there's another user with similar features who has done this. So that is your implicit feedback. User A didn't tell you, user B didn't tell you, but you can use that. So there are again pluses and minuses of explicit feedback and implicit feedback. Explicit feedback would lead to high quality ratings because you know you've asked that person, but the data is always going to be sparse because it's always a very expensive exercise to go and collect the data, and then cold start is of course problematic. Implicit feedback leads to less accurate ratings. Data is dense. Of course, you have a lot of data, but then there's a lot of assumptions built in that this is how the users want, and it is easy to correct. So this is about, in general, about recommender systems. I think we are almost done here. Yeah, we are done with. I mean, we were talking about recommender system, and if you don't talk about Netflix price, I spoke about this in my previous slides as well. I just kept this as it is because we're talking about recommender systems, and if you don't talk about Netflix price, then it doesn't make sense. So, how many of you are aware of what the Netflix price was? Everyone is? No. How much? Okay, so anyone wants to help our fellow audience here? What was Netflix price about? What happened?
They wanted to find the lesser RMSE of the for the SVD model that they built. They wanted a lesser RMSE. Like who could get that? They would get the price money. Who would have to leave.
So Netflix announced in 2012, I think. I don't know. 2012-13 that if someone could improve the system by 10%. By decreasing the RMSE value, they would give, I think, 1 million.
What is that?
Sorry?
RMSE?
Root mean squared error. So that's the evaluation metric that they were using for the system. They would give 1 million, or I don't know, 1 million. So 1 million US dollars. And yeah, so this is, I think, 2009. So yeah, so I think this team won it, and they built an ensemble model with multiple decision trees and random forests and gradient boosting methods. So you can go and check out what they actually proposed. And Netflix actually, like I mentioned, didn't put this in production. They said it is too complex an engineering effort for us to be able to put this in production for our systems. So even though we'll give you the price, we will not use this completely. So they gave away the money. They used some parts of the technique. So if you read the paper, they say that we're using some certain parts of we integrated certain parts of the solution with our existing solution, and we didn't get a 10% increase. We got, I think, 4-5% increase, but that was good enough for another billions of dollars. So Netflix made more money doing this. So 1 million is nothing. So yeah, so in the end, that's all. I just wanted to talk about the Netflix price, and now we can have a small Q&A. Okay, yeah, one last slide. So this is not a hands-on session. I'm planning to start another meetup or another sessions where we have only hands-on and we don't discuss theory like we do here. What we do in these meetups is try and understand different areas of data science from a high level, so that everyone who's trying to enter or who wants to just know about the field in general just gets an overview of that. But I think we are missing out on doing hands-on stuff, so we are going to start that. And yeah, so if you want to explore building recommendation systems in Python, you could explore Surprise. LightFM is a very popular library that people use. So these two libraries are something that, so I just took this from GitHub. So these two libraries are ones you can explore. And with this, we can have a small question and answer session and then close for today. Okay, anyone wants to ask any questions to anyone? So this is, again, open to all. You don't have to ask questions to me. If you want, you can ask questions to the entire crowd that has come in. Any question on anything, on the topic or regardless of the topic. We have around 10 minutes. We are going to wrap around 3:30, 3:45. So 10-15 minutes for that. And yeah, anyone has any questions?
This content-based the recommender system, Andrew NG actually he categorized into two categories: romance and action. So he gave actually values for each movie. So on what basis can you quantify such things to actually build that kind of a system?
So that is collected data, right? That data is collected. For that movie, he gave, so it was a romantic movie, so he said, I'm giving this value. So that you collect from either users or you collect it yourself.
Okay, so basically you use a Likert scale, and then based on that, what they say, what the users say, based on that you come to the value.
Or you do the feature engineering, not only the user, but you do it yourself. So that, and then you decide, you have certain criteria that if so and so scenes are there, I will give this value. If more than 5 scenes are there, maybe this is a more 5 romantic scenes are there, so this is a high category romantic movie. Or more than 2 scenes are there, medium, no scenes, 0. So you can categorize and then decide.
Yeah,
So that is based on the content itself. You're looking at the movie and then deciding the features. So it has to come from the content.
That collecting data for collaborative filtering will become much more easier than compared to content-based filtering. Is that the case? Because content, it is what the user preferences in case of collaborative filtering. But in this case, some people might say.
That's what I'm saying. It has to come to the. I'll tell about text because I work mostly with text. So for text, the features that we we build the features, right? So text, whatever content is there, we can vectorize. Like I said, badge of words, you can do TF-IDF, you can do word to vec. Now, how many dimensions is my word to vec model being trained for? 100 dimensions, 200 dimensions, 300 dimensions. That's a decision I take as the person who's building the system. So, and 300 dimensions means the features are going to change accordingly. If I take 200 dimensions, it will be another set of features, right? So the number of dimensions I'm reducing. So the information captured will be reduced. So that is a decision I take by doing trial and error right now. So, and that is coming from the content, that's not coming from the user. My text document is there. I am doing feature engineering by deciding how many dimensions I want. That is my choice, but that's not something that's selected to the user. So that content recommendation, content-based filtering would be like your features come from the content, not from the user, the ones you're devising.
Could you go to the slide about this? Will you give a little more explanation on cold start is problematic and explicit?
Anyone wants to go ahead? I can go, but anyone wants to. So what cold start, like I said, you want to be able to predict, but you don't have the ratings, especially to do collaborative filtering. The problem is with collaborative filtering. For collaborative filtering, you need the ratings. You have ratings for 5 people, you want to be able to rate for the 6th person based on the ratings of 5 people. You don't have the ratings, you can't start. That is your cold start problem. So how do you get that? Either you go and ask the user, tell me what is your opinion on this, or you observe their patterns implicitly, like in the case of search.
So let's take something like some other application that can explain explicit and implicit feedback. Because what I think is cold start can be reduced a little bit by just asking a simple question for like, what kind of category. Let's say I have installed a new app. So that is asking me what kind of genre I like in business. So I think cold start, let's
but
say
it's asking you.
Taking on a geographic.
It's asking you, right?
Yeah.
You're answering that.
Yeah.
So that is explicit.
Right. But
if I don't ask you, and the way you're using, I observe your pattern. You have installed an app you've never used in your life.
Yeah.
That is implicit. So I want to be able to, yeah.
But how does it, just taking the maybe geography couldn't help in all the, let's say it also depends on the application or it also depends on the kind of industry we're tackling. Implicit and explicit is what I think.
Yes, it's always going to be domain specific. Like you will have a lot of, like search, you will have a lot of implicit data. You will not get explicit data on, hey, what do you want to search for? Nobody will go and ask. So that's going to be industry specific for sure. But it's a problem. It's going to be there. I mean, there is something called explicit where you actually get the data you want, where you ask the user. I think even Google asks, right? Can you tell if this place really exists or something. They try to confirm certain things. That's not for feedback, but that's for the data collection itself. Again, that's for the data collection, and then they build systems on that.
But I know if we are recommending based on the geography or demography, it may not help in all the cases, is what I think, because it's more of the.
No, so implicit feedback doesn't mean you have to recommend based on geography. You have to be. This is you devise what is the most likely feature that can give you the, like for example, if this guy is going to use the app or not. One feature for that would be when was the last time he logged into this app. Correct? Instead of asking like, and then also Google can do this because they collect data on which apps you open at what time. So they have that information. So if they collect data from Google, the app maker wants to understand. So he can go and check which apps this person is opening. If is he opening Instagram, WhatsApp, Facebook all the time, or is he opening finance apps all the time? So this is again, this data without asking the user, you can do all this.
A lot of online learning also happens. I think.
Yes. Okay. Anything else?
What separates a recommending system from regression models? It's almost same kind of supervised learning.
What separates recommender system? Anyone wants to take that? What separates recommender systems from regression models?
In regression models, like you're actually you're dealing with the continuous target variable, whereas over here, like it is completely a different thing. Like
But
you are
connecting data, you're connecting the information.
like he used actually Android used regression to determine the parameters. That's it. Like to determine those parameters, he used regression. And like on top of that, like it is much more than regression. Like what he did in that example, like he actually came to a conclusion about the movies that were not rated.
Recommendation is one application of regression. Like he said, right? I'm using linear regression to be able to minimize this cost function and provide it. So this is one application. You can do other things with regression. Right? Not only recommendation. You have a certain target function that you want to predict for. It's not necessarily recommendation. I mean, your problem statement changes based on that. But recommendation is one problem statement that
It's kind of the same thing.
No, so he's using linear regression for that. Like I said, so can either use it. So again, recommendation can be based on linear regression, like he did for I think content based, or collaborative. You're actually not doing regression there, right? So it's a subset. What you're doing, one technique, your recommendation system, your regression, you can do much more than just recommendation. That's what I think.
Recommendation system is actually not a machine learning algorithm. Like it's like you can use any algorithm to actually build a recommendation system.
It's a use case. Okay, so if we have no other questions, then we can wrap up. I mean, anyone else? Okay, so thank you so much for being here, and yeah, that's it. Thank you for coming.